402, remove k digits. So we are just giving a number digits, so this is a string and it can have leading zeros. So for example, from before it can be 10 or it can be 010. So from the beginning it can be zeros, and we are also giving a k. So this k means we can remove the number of k digits. So for this number, for example, we can remove some numbers and the remaining will be 1219, and this will be the smallest number. We just need to return the smallest number as a string. And for this example, we can remove 43, and we can also remove another 2, so 1219 will be the smallest. But how can we solve it? So let me first go to the whiteboard to explain it. So for example, we have a number like string like 132. So what we need to do? And for this kind of number, we might we are sure if the k, for example, if the k equal to 1, it means we can remove one number. If we remove one number, it must be 3, and the final result will be 1 and 2 as a string. So the brute force is we're gonna use permutations or combinations. So for the combination, we're gonna combine from the 3 numbers. We're gonna choose 2 numbers, and from the 2 numbers, we're gonna take the smallest number. So for example, we can remove 1, it can be 2, 3, or we can remove 3, it can be 1, 2, or we can remove 2, it can be 1, 3. And from all those numbers, we're gonna choose the smallest. So the smallest will be 1, 2. But what if we remove two numbers? So for this kind of a combination, basically we're gonna choose like 2 positions. It's gonna be like say and k for the time complexity, and this will be time limit exceeded because it is to the power. It means this result is n to the power of k. It's gonna be a really big number, or n to the power of n minus k. But definitely this is gonna be a very big number. So the greedy idea is why not just choose the smallest number as much as possible, just to return the smallest number directly. But how can we do that? So for the same positions in the middle, for example, the middle position is 3. If this middle position can be changed, for example, this k equal to 1, we can remove one number. But we have 1, 3, 2. So what if we have another case, 1, 2, 2? So if we can have another number, I mean this 1 and 1 is the same, and the last digit also the same, but in the middle only this number. If we have a smaller number, so this result must be the smaller than this one. So according to this kind of idea, this kind of a greedy idea, so we can use a data structure to solve it. So the data structure gonna be the stack. So we're gonna use the monotonic stack to solve this problem. And because this is like a dictionary, it has a sequence. So for example, 1, 2, 3 is the smallest sequence because it is a string. So this kind of question is called dictionary monotonic stack. So we wanted to find the smallest string. So the sequence will be 1, 2, 3. So for the monotonic stack, we're gonna keep and maintain a monotonic increasing stack, because the monotonic increasing stack will be the smallest result, will be the smallest numbers. So for example, 1, 2, 3, it is monotonic increasing inside of the stack. So this 1, 2, 3 will be the smallest number. But how can we calculate by using the monotonic stack? So we're gonna check the numbers one by one. So for the first number, this is our stack. So we're gonna put the first number 1 inside of the stack. Because the stack is empty, so we can put it inside. Now, for the second step, we're gonna check this number 3. Because this k equal to 1. So this means if we remove just one number, so the k would be -1. Yeah, so we need also to check this k. So for the second step, but we didn't remove any number, so we don't need to check this k yet. The second step, we're gonna put the 3 inside of the stack, so we have 1 and 3. And 3 is more than 1, so we are safe. We don't need to do anything. We just put it inside of the stack. And next, we're gonna put 2. If we want to put 2 inside of the stack, we cannot do that because it is not monotonic increasing. We have to pop 3 out. Yeah, if we pop 3 out, so the k would be -1. So the k would be equal to 0. And here, after we pop out the 3, so we're gonna put 2 inside of the stack. Yeah. Now inside of the stack we have 1 and 2, but this k equal to 0. So this means we can stop the while loop. So the while loop is just needed to check if this k exists and if the stack exists, and then we can pop something out. If this k equal to 0, we will not pop anything because we are sure we removed just k numbers. Yeah. And in this example, this is just k equal to 1. So what if k equal to 2? Yeah. Even k equals to 2, but in our stack, it's gonna be the but in our stack, it's gonna be like 1, 3. We're gonna pop out the 3. Next, we put a 2. But in our stack, we have 2 numbers. But actually, we just needed to have 1 number because k equals to 2. We need to remove 2 numbers. But how can we remove this 2? Yeah, we can also use a remainder to check how many numbers left. Yeah, because the length of the string is n, and we need to remove k numbers. So what is left behind is n minus k. So this is the remainder for the numbers. So we just need to check the stack. So if the stack is a string, we just need to use a slice until to this remainder, to check the result. So what if there is leading zeros? For example, there is leading zeros inside of the stack. Yeah, but we need also to strip the leading zeros. For example, the result is 0, 1, 2 as a string. So in Python, we can use the left strip to take out these zeros. We're gonna just return 1 to 2. Yeah, but what if this result is empty? So if it is empty, we're gonna return a 0, so according to the description. Because if it is empty for the string, we don't need to return the empty string. We just need to return a string 0. Yeah. Now let me go back to the code editor to finish the coding. So as we said, we're gonna keep a monotonic stack. Yeah. So I'm gonna prepare. So the stack would be a monotonic increasing stack. Yeah, and I'm gonna prepare a remain. So it means how many numbers left. So the stack would be empty, and the remain would be length of the num minus k. Now I can check the stack. So for n in num, so this n is just a string, a character. Yeah, because I can compare characters directly in Python. So I'm gonna check this k. If k is more than 0, and I have the stack and the number. If it is a monotonic increasing stack, so the number should be less than. If it is less than, I'm gonna do something. If it is more than, I just append it inside of the stack. If it is less than, I'm gonna pop it out. Yeah. So if n is less than stack minus 1. Here, for this example, I'm gonna use just put the numbers inside of the stack. You can also put index, but for me, I'm gonna just put the string, the characters inside, because I can compare directly. Yeah. Now, I will pop it out. Before I pop it out, I can, use this k should be -1 because I used 1 time. Yeah, if I pop out, it means I just remove 1 number, one character. So the k should be -1, and the stack should be pop. Yeah, I just needed to pop out this number. Now, what I needed to do, if I jump out of the while loop, I needed to append this number. I just needed to keep the monotonic increasing stack. Yeah, and this number is actually a character. I needed to put the character inside of the stack. And finally, I just needed to join the stack. after drawing the stack, I need to keep the length. It should be until to the remain. Yeah, because after drawing stack, it's not yet the result. Maybe the stack is much longer, so we have cut it from this remain. Yeah, and also we need to strip from the left side with 0 characters. So for example, if there's a 0 characters, this is a 1 0. If there's a 0 1 0, we need to strip this 0 out. It should be 1 and 0. Yeah, so for example, it is 0 to 0 0 like that. So this 0 should be stripped out. Yeah, it should have no, it must not contain leading zeros. Yeah, we should know about that. So this is why we have to strip it out. Otherwise, if we just return an empty string, so we're gonna return this string 0. Yeah, like this example. If we remove 2 characters, it is empty string, but we're gonna return a 0. Yeah, so this is just the 2 edge cases we need to consider for the example 2 and 3. Yeah, now let me submit it to Tag. As you can see, it works. Now let me submit it. Yeah, so the time complexity would be just ON, and also for the space complexity. Yeah, because we just used a space empty array, and it prepared for the stack, and the length of the stack would be ON. And here, even we have a for loop and while loop, but the main operation consumed is the stack. Yeah, so the stack append and pop, in total there will be O2 times n time. Yeah, so the time complexity would be ON. Thank you for watching.